Here it is. This is where things start to get a little confusing if you're only pretending that you're paying attention. If you are actually taking notes, plugging these numbers into your calculator, not just waiting for the answers to pop up on the screen, then this is going to be pretty easy for you. If you're not actively involving yourself in this note-taking process, then the next few weeks might be a little painful. So let's make it easy. Let's pay attention. None of this is difficult. You can all do this. We're just not going to use words like stuff and things. We're going to use words like molar mass and percent composition. So percent composition, the percentage by mass of each element in a compound. And this is one of the things that we touched on before finals, but we are re-examining the process so that we can be very good at it before we move on. And so when we calculated this, we had percent composition is equal to the mass of the element. That means the part divided by the whole, the total mass. Remember, percent means part of 100 times 100%, and that gives us our percent composition. All right, good stuff. Let's start with the first one. And this is building, as everything does in chemistry. It is building on what we did before. And what we just finished using was the mole and molar mass. So our first question here is, what is the percent of carbon, just carbon they're looking for, in C5HNNO4, which is the glutamic acid used to make MSG, monosodium glutamate, which a lot of you eat probably without even realizing it, unless you read your food labels. It's a compound used to flavor foods and tenderize meats. So what do we have? Look at our formula. We want percent of just the carbon. If they had said percent composition, then we would have had to do every element there. But they just want carbon, so yay. That's going to be a little bit easier. So I write my elements in the order that I see them. I have carbon, hydrogen, nitrogen, oxygen. And I see here that I have 5 carbons, 8 hydrogens, 1 nitrogen. I'm just looking at the formula here, looking at the subscripts. That tells me how much is there. 4 oxygen. All right. So now I look at my periodic table to see what my masses are. So this is adding up molar mass. I'm going to have you pause the video, and I want you to do the molar mass for this compound, and then we'll take the molar mass and we'll go from there. So the molar mass that I came up with was 146.14 grams per mole. Remember, molar mass is for a mole of those atoms together, because each atom would be way too small to weigh in grams. So it's per mole. And if you didn't get the answers that I got, then when you have a chance, now if you're just watching the video on your own, or if you're in a classroom watching it, then when you get a chance, come back, see where you're rounding. Go to the hundredths place, just always round to the hundredths place from the periodic table. Multiply the mass by the number of the atoms that are there, and then add up all your numbers. That's what you should get. Okay, so we are just being asked for carbon, so we are just going to take the carbon, and our formula said the mass of the element, which was 60.05 grams per mole, divided by the total mass, which was 146.14 grams per mole, times 100%, and plug that in. What you should get is 41.09%. 0.09%. And this is your answer right here. All right. So notice that in this example, they didn't give us any masses in the problem. They just wanted to know percent, part of the whole. So we just took what the whole was, which was that right there. We took what the part was that we were interested in, and then we figured out our percentage. That was our answer. All right, so sometimes, if we look at the next slide, they may actually give you numbers. How would we do this one? Find the percentage composition of a sample that is 9.03 grams of magnesium and 3.48 grams of nitrogen. Ooh, name the compound, because that's first semester stuff that we are good at, or should be. Okay, so we've got masses for individual elements, and it doesn't tell us which one they want, which means they want them all. We need the whole. Right now we have this part, but we don't know what the whole is. Well, you know what? If we just have two things, we have these two parts, and we know that they come together to make up one thing, we can just add the masses together. So just add them, and the total mass should be 12.51 grams. And what would this be if I put this together? I have magnesium, I have nitrogen, and what I should be doing is looking at the periodic table and looking at where these guys are. So magnesium is here. It's a cation in group 2A, so it's going to be a +2 charge. Nitrogen, when it becomes an ion, will be nitride, and it's in group 5A, which means it has 5 valence electrons. It's going to need 3 more. This is going to be -3 because it's going to gain 3 electrons. All right, so when I put these together, whoa, that's not what I wanted to move. I wanted to move you. Okay. We are going to write magnesium with its +2 charge, nitride with its charge. And so, oh, how did I know that this was going to be ionic with ionic charges? Because this guy here was a metal. All right, semester 1, coming back to you. When we put these two together, I cannot just put one of each together because a +2 and a -3 will not a neutral compound make. So the quick and easy way that we learned was our crisscross method. Our formula is going to be Mg3N2. And the name for that will be magnesium nitride. For ionic compounds, you just name the ions and that's it. This was not a transition metal, so I did not need to use any Roman numerals. So we did the naming part check. We still need to do percent composition, so let's get to that. We know that we have 9.03 grams of magnesium. Yay, they already told us what we needed. That's the part out of the whole of 12.51 grams. Grams of Mg3N2 times 100%. Plug that into the calculators. Plug it in. Plug it in. Hurry, hurry. I'm going to give you the answer, and you better have something on your calculator. Ready? All right, so for magnesium, you should have 72.18% magnesium. And don't skip out on the units, especially on your answers here. So this is for magnesium. We're going to have another percent for something else, and we need to be able to tell the difference between those two. We need to be able to know which percentage goes with which number. So the next one is our nitrogen right here. So nitrogen was 3.48 grams out of 12.51 grams of magnesium nitride times 100%. Calculate it. Punch it in. It shouldn't take that long. All right? So once you do that, we should get 27.82% of nitrogen. So those are the answers. That is our percent composition for this compound. Right now, I see you all in class when you are working through these problems, and sometimes you're taking your time pressing the numbers on the calculators. You really need to get proficient at using it because the problems are just going to get hairier and hairier from here. So this is easy stuff. Let's just do this over and over again, and you will see just how easy it is. Right, so, All right, let's move on to percent composition of water. And if you're running out of room on the PowerPoint handout that I gave you, you can just move on to the lined paper in your journal where you're supposed to glue this in. That's what that lined paper is going to be for, in case you need that extra space. All right, so they want to know the mass percentage of water. Yay, they don't want the whole thing. They just care about the water. In calcium chloride dihydrate. If I look at my formula, calcium, calcium, chloride, chloride. Because it's ionic, it doesn't matter how many are there. I just name the ion. Dihydrate. So this is a special kind of compound that has water attached to it. And the di tells us that there are two waters. And this kind of makes sense if you think about the fact that water is actually a covalent compound. So the di shouldn't be a surprise for us there. There's two hydrates. It just so happens that it is part of the structure of this overall compound with the calcium chloride. So it's all together, calcium chloride dihydrate. So we still have to find our molar mass. We still have to find the mass of everything that's present. Let me break it down for you. We've got calcium, 1. Chloride, chlorine, there are 2 of them in our formula. And the next element is the hydrogens. And if I'm looking at what is here, there's 2 hydrogens in H2O, but then this 2 here tells me that I've got 2 of this whole thing. So I'm actually just going to multiply. 2 times 2 is 4. So I have 4 hydrogens and oxygens because that 2 is multiplying the whole group there. There's 2 oxygens. All right, so find your molar mass. Pause the video. Have someone pause the video. Find your molar mass. Hopefully for your answer, you got 147.02 grams per mole, or something very, very similar if you're rounding in the right places. And now, as we find our percentage, since we're just interested in water, what we're going to do is we're going to take just the elements that were involved in the mass of water. And we're going to add those together and use that for our percentage. So if we add 4.04 plus the 32, I get 36.04 grams per mole. But I want you to confirm that you get that. So pause the video one more time, make sure that you add those together, and then once you have that, calculate your percent composition. Once you all have your percent composition, let's unpause the video. The answer here is 24.51% water. So make sure that you can get that answer, and if you didn't, go over your work, see where it is that you are either plugging something in wrong in the calculator, or maybe you're rounding and not getting the numbers that I have up here. And once you're ready to move on, let's work these here. I'm going to give you all, have you pause the video, check your answer. I'll have the answer here in a few seconds, so just pause the video, work this out, and then check your answer. All right, so we are reviewing things from first semester here, just to make sure that when we start writing equations, you know how to get these formulas written down. And so CO2, remember we always look at the first element. Carbon is a non-metal. And that is our clue here, that because carbon is a non-metal, it is covalent, and covalent compound naming rules apply. Right? So the name is carbon dioxide. We use prefixes for covalent compounds. So after that, 4% composition, I added up the molar masses. We had 44.01 grams per mole. I put down, when I wrote down the work, grams per mole of carbon here, grams per mole of oxygen here, and then again, make sure to write that element as part of your unit. You absolutely have to start doing that. This needs to be made clear in your work which element you're talking about, because when we do empirical formulas next, it is going to be absolutely essential that you have that distinction. All right, so try the next set of problems, and pause the video first, try your next set of problems, and then unpause and check your answers. Here are your final answers. Make sure that you have your notes with you to help you with your homework.